everyone. So today we are going to discuss 2024 paper. So let's start with the first question that we have in the paper. So the first question says that you have to find the solution of the differential equation that is given by x dy dx plus y is equal to x cubed y to the power 6. So let's see how we can solve it. At first, we have to take it in the form. So we can see that it is a first order, first degree linear differential equation. Now we do what? Since we are having x cubed y to the power 6 on the right hand side, we are dividing the whole equation by x into y to the power 6. So the x are getting cancelled and we are having 1 by y to the power 6 dy dx plus 1 by x into y to the power 5 is equal to x square. Now we are doing what? We are considering 1 by y to the power 5 to be our z. So since z is our 1 by y to the power 5, we consider dz dx is equal to minus 5 by y to the power 6 dy dx. So we have what? 1 by y to the power 6 dy dx is equal to minus 1 by 5 dz dx. Now here, since we are having 1 by y to the power 6 dy dx, we are going to substitute the value of 1 by y to the power 6 dy dx here. So here we are having minus 1 by 5 dz dx. We are going to substitute that. So we are getting minus 1 by 5 dz dx plus, and since we have considered 1 by y to the power 5 to be z, so we'll get plus z by x is equal to x square, right? So we are having dz over dx, and since we are having minus 5z into 1 by x is equal to minus 5x square. So this is of the form dz by dx plus pz is equal to q, where we can say that our p is minus 5 by x and our q is minus 5x square, right? So our integrating factor will be e integration minus 5 dx by dx. If we put it in the integration, we get e to the power log x to the power minus 5, which is equal to x to the power minus 5, and that gives us the integrating factor to be 1 by x to the power 5, right? So from here we get z into 1 by x to the power 5 is equal to integration minus 5x square equal to 1 by x square dx. And then if we solve it and then after simplification, we get that this is going to be our answer. Now, if we look into the options that they have given, from there we can simply say that option A is going to be our correct option. Okay, that's good. Now let's move to the next one. So it's a pretty calculative problem, but I think we can solve this one, right? Okay. Now let's see, this is a linear algebra problem. So we have the eigenvalues of a 3 by 3 matrix. So eigenvalues are given to be 6, 5, and 2. Now we have to find the determinant of A inverse transpose, right? So we have the eigenvalues to be 6, 5, and 2. And we know that the determinant of the matrix is what? It is the product of the eigenvalues, right? So the product of the eigenvalues gives the answer to be 60. Now, if you want to find the determinant of A inverse, it is what? 1 by determinant of A, which is 1 by 60. And this is going to be 0.016. Now we have that determinant of matrix A is going to be determinant of the transpose. So if we consider A inverse to be matrix B, so we can say that determinant of B is equal to determinant of B transpose. So from there, we know that determinant of A inverse is what? Determinant of A inverse is 1 by 60, which is equal to 0.016, and that is going to be our determinant of B transpose, which is A inverse transpose, right? So from there, we can see that the required determinant that they're asking, that's a pretty easy problem. That is going to be our option D, right? Okay, now let's move to the next one. Okay, they have given us the set of all real numbers except minus 1. So we are considering the set of all real numbers except minus 1, and we are defining the binary operation star to be A star B is equal to A plus B plus AB. Now we want to find the solution of this equation, right? So this is also a pretty calculative problem. So at first we have what? We have been given that A star B is what? A plus B plus AB, right? Now we have to find 2 into x into 3, right? So if we try to do it with the associative property, let's apply the rule on 2 into x, because we are defining the binary operation. So the binary operation can be defined on 2 elements. So 2 into x is given as 2 plus x plus 2x multiplied by 3, and this is equal to 7. So 2 plus x plus 2x is going to be 2 plus 3x multiplied by 3 is equal to 7. Now again we are going to apply the operation on these two. So we will consider this to be our a and we are going to consider this to be our b. So we have what? A plus b plus ab, right? So a is 2 plus 3x plus 3 plus a into b. So 2 plus 3x into 3, that is going to give us 7. Now, after simplifying, we get 2 plus 3 plus 6 plus 3x plus 9x equal to 7. Then we solve for x, and after solving for x, we get the value of x to be minus 1 by 3. Okay, so if we look into the options, we can say that our option A is going to be the correct option, right? Okay, now here they are saying that suppose W is the Wronskian of two linearly independent solution of the differential equation. So we have that this is our differential equation that is given to us, and they have defined W is what? It is going to be the Wronskian, okay? And then for all values of t, we are going to get a constant c. So what will be the Wronskian is going to be, okay? That's they're asking. They're asking about the Wronskian. Okay, so now the given differential equation is of this form: 2y double dash plus y dash plus t squared into y equal to 0. Now we do what? We divide the whole equation by 2, we get this. Now if we compare it with the Abel's formula, so Abel's formula, we have the form is y double dash plus pty dash plus qty equal to 0. Then our Wronskian is going to be, this is also the formula which we have to remember. The Wronskian of t is equal to c e to the power minus integration pt dt. Now, if we compare these two, we can see that our pt is half and q2 is t square by 2. We don't need q here. We only need p here. So, it will be c e to the power minus half dt, which is going to be c e to the power minus t by 2. So, this is going to be the required Wronskian, okay? Now, if we look into the options, from there we can say that option B is going to be the correct option, right? Great. Now let's move on to the next one. So here they have given us that sin z equal to 10. So this equation is going to be what kind of solution that we have to calculate. Remember, okay, so we might there might be a mistake while we are doing this. Remember, this z is a complex number. So when we are defining sign of a complex number, we know that the range is going to be our whole complex plane. So we are going to get a z on which the sign is going to take the value 10, right? Okay, let's see. Okay. Okay, now we have that sine pi is equal to 5, right? Okay, then we have w is equal to what? Sine z, that is going to be 10, right? So u plus iv is going to be 10. So you have u is 10, v equal to 0. So we have this point. From there, we can say that we are going to get infinitely many complex solutions, okay? Great. Okay, now they are asking you to match the list 1 to list 2. So they have given you particular differential equations and they have given you the particular integrals of each of the differential equations. You have to solve each of them and you have to find the solution. Okay. Okay, let's see. Okay, this is going to be a pretty big problem. Okay, so the first one we have for the option A, we have d square plus 6d plus g into y is equal to e to the power x. So our particular integral is e to the power x over d plus 3 whole square. Now, since we are going to particular integral, so for e to the power x, the d is replaced by 1 because you have e to the power ax. So the d is replaced by e. So you have e to the power x by 1 plus 3 whole square is e to the power x by 16. So this is the particular integral of option A, right? Now for B, we have d square minus 3d minus 4y is equal to 2 sine x. Now yn is equal to a sine x plus b cos x. Y dash n is equal to a cos x minus b sine x. And y double dash is going to be in this way. So from there, if we solve it, we have a sine x. We are using the undetermined rule, right? Undetermined way. So have a sine x minus b cos x minus 3 into a cos x minus b sine x. And if we put it, we solve for a and b. Solving it, we got a to be this and b to be this. So from there, we can say that this is going to be our particular integral, right? Now for option C, we are again using the rule. So you have minus 8 e to the power x cos 2x over d square minus 3d minus 4. So I have minus 8 e to the power x d plus 1 whole square minus 3 into d plus 1 minus 4 into cos 2x minus 8 e to the power x d square plus 1 plus 2d minus 3d minus 3 minus 4 into cos 2x minus 8 e to the power x d square minus d minus 6 cos 2x, and from there in place of d square we are going to put 2 square minus 2 square, so we have minus 4 minus d minus 6. So we have what? Minus 8 e to the power 6 minus d plus 10 cos 2x. Now since we're having only d, we cannot apply it in cos 2x, so we are going to rationalize and multiply and divide by d minus 10. So have d minus 10 into cos 2x. Now, if we put it again, so we have d square minus 100 in the denominator. Again, in place of d square, we are going to put minus 4. So we have minus 4 minus 100. So you have 8 e to the power x d minus 10 cos 2x over minus 104. Then you have 8 e to the power x minus 104, a derivative of cos 2x plus 8 into 10 e to the power x over 104 cos 2x. Solving it, we got this. So from there, we can say this is the particular integral for option C. Similarly, we have e to the power minus x in there in the option D. So in place of D, we are going to put minus 1, and solving it, we got this is to be the particular integral for option D, right? So from there, we can say that which one is correct. We can simply determine that this is for option D. So D is going to be matched with 4. So option A is going to be our correct option, right? Okay, great. Now let's move to the next one. So we have W is the solution space of the differential equation. So we have to find the dimension of the solution space. It's pretty easy to understand because here we can see that we are having three-dimensional equation, right? It is a three-order differential equation. It's a homogeneous linear differential equation. So from there we can see that the solution space for this homogeneous linear differential equation is going to be of dimension 3. So from there we can say that we are going to get 3 linearly independent solutions. Okay, so option C is going to be our correct option. Okay, now here they have given us uxs plus xuyy equal to 0. So they are asking on under which condition it is going to be elliptic, hyperbolic, or parabolic. So let's see. Okay, so here we are having it in this way. We know that the general form of the homogeneous linear differential equation is given as a d square auxx plus buxy plus CUYY is equal to this. Now this is going to be elliptic if b square minus 4ac is less than 0. It is going to be parabolic if b square minus 4ac is equal to 0, and it's going to be hyperbolic if b square minus 4ac is greater than 0, right? Now from if we compare it with the equation that they have given, we have a is equal to 1, c is equal to x, b equal to 0. So from there we can get that b square minus 4ac is equal to minus 4x, right? And from there, we can say that for x is less than 0, this is going to be greater than 0. Hence, we can say that it is going to be hyperbolic if x is less than 0, right? Okay, great. Okay, now let's move to the next one. Okay, now they have given us set under on which set this fx equal to x square is going to be uniformly continuous, right? Okay, let's see. Okay, now if we look into the curve, if we look into the graph of this, it is a continuously increasing function. So if we take the bounded set, under bounded set, the continuous function minus 1 to 1, it is going to be uniformly continuous, right? So from there, we can say that it is uniformly continuous on the closed interval minus 1, 1, right? Okay, great. Now suppose we have to find which of these is a subspace of R to the power R cube. So if you look into the option 1, you can simply see that 0, 0, 0 does not belongs to W for option 1. Why? Because if we put 0, 0, 0, we are not getting minus 2 on the right hand side. So this is not a subspace. For option B, if we talk about the linearity property is not satisfied here. So from there also we can say that it is not a subspace. Okay, for option D, if you look into the option D, the x should be belonging to Q, right? But if we talk about C, let's say C equal to root 2, then C into x comma y comma z should also belongs to our W, right? Because C is a scalar. If we multiply by root 2x comma y comma z, so from there we can say that the first element does not belongs to Q, right? So from there we can say that this is not a subspace, hence our option C is going to be our subspace, okay? So let's see how the solution has been given, okay?